We are looking at lesson 60 today. This homework will be due whenever you come back from the break. Don't forget to do it, Melina. Okay? Do it tonight so that you don't have to worry about it. And then you won't have to worry about it Sunday, January 5th. Or Monday morning, January 6th. Okay? If you do it now, you'll be done with it. I don't know, maybe you'll have a class. That's the day before we come back. Yeah, that's what I'm saying. So do it today, and then you don't have to worry about it. All right, so theorem 61, talking about the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other sides, it divides the sides proportionally. We learned a few lessons ago that if they were parallel and they went through the midpoint, then the sides were congruent. But does this parallel line go through the midpoint of either side? It doesn't tell us that it does. So it's not that A and B are congruent, but A over B is equal to C over D. Yeah, even if it is the midpoint, the proportions still hold. So don't automatically assume that it goes to the midpoint just because they're parallel. So we want to find the value of y. Any ideas what we would set up? The proportions. What would we do for our proportion? Four over y plus 1. Do you agree with Bonnie? Yes? Any questions on setting up the proportion? Okay, will you solve it? Do you need a note, Bonnie? Do you agree? Any questions there? Okay. Looking at the next theorem, it's the converse of the triangle proportionality theorem. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. is the kind of question that they'll ask to use the theorem 62. How do we figure out if they are parallel or not? Set up a proportion. Okay, what would the proportion be? Would that work? Okay. What is 3 times 12? What is 8 times 4.5? Yes. Since they equal each other, they are parallel. If it wasn't equal to 36, would they be parallel? No. That makes sense? Questions on this one? Okay. Another theorem. If parallel lines intersect transversals, they divide the transversals proportionally. You did these last year in Algebra 2. We did them at the beginning of the year. Do you remember that kind of picture? Okay, hold on. If you don't remember it, does it look more familiar? They were always turned. Huh? Oh. They were always turned like that last year. Like they never had them turned the other way. Okay. So see if you can find the values of x and y by yourself. Okay, what would you do to find x? Why? Because it tells you they are congruent. Does that make sense? When you have parallel lines, though, they aren't always congruent. But it tells us in this one that they are congruent. Does that make sense? So what did you get for x? Any questions there? Okay, what about for y? Okay. And then what are you going to have to do? And do what? How will it factor? So y equals 2. Does that make sense? Any questions here? Okay. Another theorem. The last theorem for today, actually for the year. If parallel lines cut congruent segments on one transversal, then they cut congruent segments on all transversals. So going back to that example we just did, since we knew that these two segments were congruent, those two had to be congruent as well. Does that make sense? If these two are congruent, those two have to be congruent. And that's all that this theorem is saying. See if you can figure out UV. Will someone go work it out on the board? Did you get 20? Any questions there? Okay. Looking at another example. They want you to determine whether the lines are parallel when x equals 5. How many think they are parallel? How many think they are not parallel? Why? The length of AC is 17, and the length of CE, so are those the same? So the lines can't be parallel, right? Any questions there? Okay. This is a picture of a railroad track. Obviously, yes, railroad tracks are more accurate, but we're looking at it from an angle. We're looking at the picture of it, not an actual railroad track. Does that make sense? So they're taking it at an angle, and then they give you this information. Any ideas for the length of PQ? None? It is a decimal. No? What? Okay. That's 25, right? And that's 20, right? So what does this part have to be? You with me so far? Okay. And then it tells us this is 5 and this is 8, right? So what is this whole thing? Does that make sense? And we're looking for this part right there. So we could say x over 5 equals 13 over 20. Does that make sense? Do you see how that works? Because these two aren't the same values, because you're looking at it from an angle. They are proportional though. This one's 5 and this one's smaller because from the picture, it's further away. Does that make sense? Like in real life, yes, they would be the same length. But we're looking at the picture only. Does that make sense? Okay. So what would x have to be? Does that make sense? Any questions there?